Hello, today we're reviewing Quantum Entanglement by Jed Brody. This is part of the MIT Press Essential Knowledge series. I've also read Neuroplasticity, part of the same series. So Quantum Entanglement is a pretty small book. It's about 140 pages, 146, and it is about how two atoms affect each other. So the book starts out pretty strong, gives some good examples on what quantum entanglement is. For example, the main idea is whether or not something has properties before you observe it, or if they assume those properties upon observation. For example, you flip a coin, you catch it in your hand, you flip it upside down, you hold it in your hand. While you're holding it in your hand, is it heads or tails, or is it undecided? And is that coin undecided until you look at it, revealing if it's heads or tails, or is it heads or tails all along, already having those properties? Another way to think of quantum entanglement, so it kind of stems from that theory, is say you have two coins, and in these examples both come from the book. You have two coins, you mix them up in your hand. One is the year 1999, one is the year 2000. You hold them out in front of you. You have no idea which is which. Well, when you reveal one, let's say it's 2000, you now know that the other one, unobserved one, is 1999. And that is quantum entanglement, how the observation of this one affected this one. So the book starts out with those examples and gradually gets a little bit more difficult to understand as he starts talking about protons and electrons. But it does get really hard, and for someone who, like me, who's not very smart, it gets pretty difficult to understand, especially when you aren't fully aware of what's happening with a polarizer when it affects a proton, which is what is talked about a lot in here. The book's writing, however, is understandable. There's a process you're able to follow and go along. There's not a lot of words that are too beyond an understanding. There are some good ideas in here, and there are some philosophical questions in here. What I really do like about this book is that he leaves it pretty open-ended. So towards the end of the book, he starts explaining against a lot of the arguments that were explained throughout the book, and allows you to kind of believe what you want to believe, because this is still like a widely debated area of physics. There's two major ideas that this all stems from, and it's locality and realism. So realism is the belief that objects have properties that exist totally independent of whether anyone is observing them. So for instance, you flip the coin, you put it on your wrist, you don't look at it, it's still heads or tails, regardless if you've observed it or not. Locality is the belief that the observation of one object cannot affect a distant object. So with the two quarters, you look at one, it's year 2000, the other one was 1999 all along. This did not affect this one. And then there is local realism, which is just the combination of those two ideologies. And then most of the book, honestly, a vast majority of it, goes along to argue against local realism, and how a lot of in physics, especially when it comes down to the photons and electrons going through polarizers, that local realism breaks down, and it seems to be that particles and things change upon observation, but it's something that we can't really measure, because once we observe it, it's already changed, especially if localism is incorrect and the observation of one object does affect a distant object that it's entangled with, then you can't even measure the effects, because once you observe it, it changes. However, at the end of the book, he does try to give some local realism, some backup, and kind of say why this could be a real thing and how we would like to believe it. It is common sense. We'd like to believe it because it keeps our reality intact, but there's not very much to back it up. And it seems like the author does push more for what Einstein called spooky action at a distance, which is quantum entanglement. But it seems like he's really pushing quantum entanglement. So overall, I give the book probably a 5 out of 7. And I give it that because he talks so much about protons and polarizers. He doesn't really give any other examples besides the quarters. And he only gives the quarters within the first chapter, and that's it. I would like to have seen more practical examples, but there wasn't a lot of those. There was some computer examples and stuff like that. However, overall, it was an informative book. I learned some stuff from it, and the word word choice and the flow of the writing was pretty well. So I do give it a 5 for that. So awesome. Quantum Entanglement. Yeah, not bad. Thanks for watching.